So we are finishing up our Towers of Hanoi thing, right? So the homework for today was to, let me share the screen. Homework for today was to finish, so implement our game object such that it creates 3 towers, fills the far left one with 3 disks, and then displays the 3 towers. And I kind of said you can do these vertically, so you don't have to try to make any sort of fancy schmancy user interface. We're just looking for functionality here. So let's go ahead and write that. I'm going to come over here. We've already created disk and tower. So here's our game that we thought about implementing last time. So we have a collection of 3 towers, which maybe is going to be an array. So let's say this is an array of 3 towers, 3 disks starting at the far left of the tower. So a tower itself is a stack. So we already know about that. I think we tested that last time in our main. If I flip over here, let me hide this. This is semaphore stuff, different class. Let's see. We're in a new folder now, right? So here is our game. Okay, yeah, we started writing this guy, but if we go into driver first. So in driver, last time we tested it. So we created 3 instances of disk. We created a tower. We then pushed the disks onto that tower. We happen to not have our towers following the rules of Tower of Hanoi yet. So we're not policing whether or not you're allowed to put a larger disk on top of a smaller disk, but that's okay. And then we showed that the towers can display. So we're going to be putting this stuff into our game now. So let's go into game here. And we've already started off by having a, for our private section, we have our array of towers that we'll actually put some towers into. All right, then a game has a constructor that will take no parameters because we already know what a Towers of Hanoi game looks like. A Towers of Hanoi game is going to have 3 towers, which we're going to add to this array of towers, and it's going to have 3 disks that start off in the far left tower. All right, so let's go into, do we write game CPP yet? No, we just started this, so I'm going to go ahead and steal. We'll just write it over there. This is going to be game.cpp. We will include game HTTP. Ninja. Okay. And then we're going to go ahead and we'll say game takes no parameters. And then we're going to have our void game display, which also takes no parameters. So our constructor here for game is going to go ahead and create our 3 towers. So we'll say this, the towers at bucket 0 is equal to a new tower. All right, and right now it's not going to know about, actually it does know about tower because tower was defined inside of game HPP. Over here, it had to know about tower because we had a private member here of type tower. And we're going to do the same thing for our other 2 buckets, bucket 1, bucket 2. Then we're going to go ahead and create our 3 disks. I'm going to go ahead and steal that from driver. Actually, we don't even need to give them variables at this point, so I'm not going to steal that from driver. So we'll go back into game CPP. And we're going to put 3 disks into the far right or far left tower. So we'll say this, the towers at bucket 0, which is a tower. We're going to push a new disk of size 3. And then we'll push a disk of size 2, disk of size 1. All right, and then for display, we're going to go through our 3 towers. So we'll say for int I is equal to 0, I is less than, and what I'm going to actually do here is I'm going to put a define, you know what? Well, say max towers is 3. So I is less than max towers, I plus plus, because arrays in C++ don't know how to report their length. All right, so have we looked at a define statement before in here? I don't recall.
No, I don't think we have. We had.
Yeah, so this guy is something called a macro, which effectively says replace all occurrences of max, what do they call it? Max towers with a 3. That's what a macro does. So this kind of creates this constant value, but instead of me hard coding a 3 down here, I just put max towers whenever I need that value for max towers. And then I give it its value here. I can actually even define this inside of the header file, which is actually probably the better place to define it. So if I go into game HPP here, I would probably define that in here. So my game is actually for max towers, it's not a 3, it's a max towers, number of towers, even though we're doing this as max towers. Similar as a 3, that's why I have the 3 up here. So similarly in our game HPP, we would probably have a for loop for int I is equal to 0, I is less than max tower. Actually, we would probably say this. Oh, it's not an instance variable of it. Less than max towers, I plus plus. And then we'd say the towers at bucket I equals a new tower. Okay. Now, similarly, we could also do max disks. You know, if we wanted to make this as generic as possible, I wasn't necessarily expecting this on the homework assignment, but we'll go ahead and add this. So we just add a little bit more knowledge in here. So I'll go ahead and define max disks. So I know some of you who've been playing the Towers of Hanoi game, you realize that you can, you know, versions of the game have more towers than 3, and some of those have more disks. How do we spell our disk? All right, so we'll start with 3 disks here. And then in game CPP, we'll do a for int I equals max disk. I is greater than 0, I minus minus. then we'll go ahead and push our discs on in the correct order. So with max discs currently being a 3, we'll push on a new disc of size 3 first, then it'll become size 2, then it'll become size 1. So this allows us to have a generic collection, and we'll see this here in a few minutes when we go to our display, where we can have multiple towers. All right. So now under display, what are we going to do? We're going to go through our collection of towers, asking each of those towers to display itself, because we've already taught a tower how to display itself. We already wrote that. So we'll say this, the towers at bucket I display. Yeah, we have to do the arrow thing here because actually this guy is a tower pointer. All right, so that should now display it. So now if we go to driver, we'll take all this junk out. We'll include game HPP. We'll say game pointer. We'll call this guy the game is equal to a new game. And then we'll say the game display. And we'll go ahead and run this dude. I'm actually going to give ourselves another tab. So I can just always have a tab for CSC300. GCC star.cpp. Oh, sorry, it's G++. And then slash. So there is our towers, but the next 2 towers are empty. So actually, let's just so we can prove it's working here. Inside of tower CPP for display, why don't we go ahead and ask the question, if this count is equal to 0, we'll do a cout empty tower. And then we can just return, because that's all that should display if we have an empty tower. Otherwise, we'll go ahead and do our displaying the stuff in the tower. So there's our first tower, which has the 3 discs in it, and then 2 empty towers. So I think, does that solve for the homework assignment? Is that everything you were supposed to do for the assignment? Yay, nay, maybe. Let me look. Since nobody's talking to me, let's look. Implement game such that it creates our 3 towers, fills the far left one with 3 discs, then displays the 3 towers. All right, seems to accomplish this. And then because we've written this generically, you can see here that I can change. If I go to game HPP, I can say that I actually want to have 8 towers with 15 discs on them. And then when I go and run this, I get my 15 discs here, and then the other 7 towers are empty. All right, so that's the advantage of writing this generically, where I can choose the number of towers and the number of discs. And then when I implement this guy, I implement it in terms of the number of towers and the number of discs, rather than hard code it. But for the assignment, if you hard coded it, that's fine. All right, so let me switch it back before I push it. Questions about this? Okie dokie. We'll go ahead and push this. All right, now, another thing, keep in mind, I know some of you were messaging me last night, struggling with some of this stuff. Again, you're supposed to struggle with it and have some bugs and things like that. Eventually, you'll get to the point where you'll be able to just sit there and write it and have it pretty close to work the first time or something like that. So just because you're not at that point yet doesn't mean you're not where you should be. You should still be struggling with the stuff and having weird pointer problems and stuff like that. All right, so right now our game looks like this. And I delete a dot out when I push. So now what we want to do is we want to have some sort of loop that allows us to pick our source tower, pick our destination tower, and then kind of allows us to move disks around, that type of thing. All right, so we're gonna have to have kind of like a play game loop. One thing I'm gonna do first is I'm gonna go ahead and label each of my towers. I'll actually give it an extra space at the end of display for tower as well, so we have some separation here. But I'm gonna label each tower with its number. That way, when we choose, we can say, I want to pop off tower 0 and push it on to tower 2. Something like that. That'll be our cadence for playing the actual game. All right. So after we tell a tower to display itself inside of game, we'll go ahead and do a cout tower number I and L. I think I could actually do 2 endls and that'll kick it down 2 lines. And for this guy to work, I have to have a include IO stream. And then using namespace std. Happy again? Actually, I'm going to move this into, it is this, isn't it? Like that. All right, and the reason I'm going to put this here inside the implementation is the IO stream stuff has something to do with what when we're actually implementing it, not when we're designing it. So that's why it probably belongs inside of the CPP file, not inside of the HPP file. Even though we could have put it in here, it would be just fine. It just so happens that we're not actually going to need this stuff until we actually implement it like we're doing in here. All right, what's this guy screaming about here? He doesn't like max disk. Oh, I just hadn't saved it. It's fine. All right, so, and by doing 2 endls here, it'll kick it down 2 lines. Let's go see what this guy looks like now. So there's our tower 0, tower 1, tower 2 with some spaces in between them. All right, that looks reasonably good. So now what we want to do is we want to start prompting the user for the source, then the destination tower. All right. And what we want to do right now is we want to just allow them to move stuff around. We're not applying any of the Tower of Hanoi rules yet. We're just going to allow them to move stuff around and to display the board. So go back in here. For game, we're going to add another function. And actually what I'm going to do is I'm going to move display into the private section here, because we're not going to call display externally to game. What we will call externally to game is play, and play will then call the display function. So we'll have the play function here, and this guy will return nothing. And let's go and implement it in game CPP. So now for play, what do we want to do? We want to, in a loop until there's a winner. So for right now, we're just going to say while true, do something. So we're just going to keep doing it forever right now. And what we want to do is we want to ask the user, what's the source tower? Then ask the user, what's their destination tower? And pop from the source and push on to the destination. Let's make sure we've implemented in tower the pop function. So we have, and it takes a disk pointer off of there. And have we actually implemented pop? We have. Notice here, because I moved display into the private section, it's no longer callable right here, which is fine. We're going to be changing that here in a few minutes. All right, so let's go back into game CPP. So for play, we're going to ask them, we're going to say cout source tower. And then we're going to read something in. Isn't the error like that, or is it like that? I think it's the error like that. We'll say cin. I'm going to create a couple of int source destination. So we'll give ourselves a couple of variables here. So we're going to read this guy into source. And then we'll do the same thing for destination. So prompt for those two values, read in to these two variables. Now, one thing that we have, I don't think that, have we done this? Have I shown you this before? Oh, what's it not happy about? Oh, sorry. That's not going to let me do what I want to do. I actually want to. We'll read it into, actually, I think it'll read in right. I just want to test this real quick. So let me just do a cout source +1. I just want to know if it'll let me do math with this guy. And that's end L. So again, this is something similar to what you would do as a programmer. I'm not exactly positive how it's going to read it in. Since this guy is an int, we'll cin do the smart stuff to read it in and convert it to an int for me. Or I think the answer is yes, it will. So now when I print it out, if I do source +1, it should do math with that value, proving to me that it read in an integer and not the string version of what I wanted. Otherwise, we'll have to read in the string and use that A to I to convert it. A to I is equivalent to like integer.parseInt in Java. It turns something that is alphanumeric, like a string, to a int, A to I. All right, but let's just go ahead and test this real quick just to make sure it's giving us what we want. So go back into driver, and we'll just call the play function, even though we're not actually playing yet. I just want to make sure I'm reading stuff in the correct way. So I'll say 2, and it doesn't matter what. So I should get a 3. Yep. So it did read it as an int and do the smart stuff of converting when I typed in a 2, because I was using cin as opposed to cout. Cin is like scanner in Java. This allowed me to read it into an integer, and it did the conversion for me since I was expecting an int. And then when I printed my source tower out +1, it gave me a 2 + 1, which is a 3. So I know it's a numeric type. All right, I'm in an infinite loop right now, so I'll just do Control-C to break out of that. So that killed the program. Now we'll go back in and we'll finish writing this. All right, so we have our source and our destination tower read in. So now what we want to do is we want to pop from our source, push to our destination. So I'm going to go ahead and give myself a disk pointer temp. And we'll say temp is equal to this, the towers at bucket source dot pop. So I'll pop off the source tower, and then I'll say this, the towers at bucket destination dot push, and I'll push temp onto that tower. And the very first thing we'll do at the top of this while loop is we'll tell it to display our board. Okay, and then I'm just going to put a little separator here. So I'll do cout, and I'll just put some asterisks in here. That'll kind of divide between our boards. I'll do 2 end Ls. Again, just give me an extra space. Oop, Ninja. All right, so that's what play does. Play forever, as of right now, displays our board, asks for the source, reads it in, asks for the destination, reads it in, goes ahead and pops from the source. It doesn't check to see if you gave it legal values yet. It'll pop from the source, push on to the destination, draw this little separator line, spin back up, and display the new state of the board. So this should allow us to go through and see that we're able to manipulate our game board. All right, so here's the current state of the board. We will pop off 0, and we're going to push onto, I don't know, let's just push onto 1. So now here's the new state of our board. Now we'll pop off 0, we'll push onto 2, new state of the board. We will pop off of, well, since we're not applying the rules right now, we can pop off of 2, push onto 1. So now we see that this is actually the legal state of the board, but we're not policing it yet. We can pop off 0, push onto 2. Pop off 1, push onto 2. Pop off 1, push onto 2. And now we've moved our stuff all the way to the far right. We're not declaring winner yet or anything, but At this point, this guy now allows us to move our play our game, right? Without policing the rules. We can move discs around. Okay, so questions about that. So how do we know that there's been a winner, generically speaking? So the way we've written our code right now, how do we know that there is a winner and we should actually break out of this loop? Because right now I'm still going. We know as human beings that we have a winner because all of the discs are on that last tower, but nothing keeps me from moving it back. You know, I can keep going and now there's no longer a winner. So how do I ask the question? How do I say keep playing as long as there is there's not a winner? What's the if statement that says we have a winner here? Go ahead and spend a minute or so thinking about that, and then I'll ask the question, and I expect somebody is going to respond and not pure silence. Because I promise I know how to do it. That's not going to help any of you. All right, what do you got for me? How do we ask the question? Keep going until there's a winner. I want to update this line. And I vow to sit here in silence until somebody answers. Actually, I should check. Do I still have people on? Yeah, we still got 13 people. How do I ask the question? Keep going as long as there is not a winner.
I think someone responded in chat.
Oh, did they?
Yeah.
It's usually Emily's job. Ask if all discs are on the rightmost tower. Okay, where's the rightmost tower? How do I refer to the rightmost tower?
The rightmost tower is tower 3.
Well, it is tower 3, but how do I programmatically refer to, for in our version of the game right now, it's tower 3 because our it's tower at bucket 2, right? Because
Right.
our max towers is currently set to 3. So what is the generic way of referring to the far right tower? So this, the towers. Let me close this guy here. This, the towers at bucket max towers -1. So is this the far right tower? Or did I trick you?
It's the far right tower.
That's the far right tower. All right. So how do I ask if all the discs are not on the far right tower? At what point is the far right tower in a win state? Because I want to keep going here as long as the far right tower is not in a win state. So what does it mean for the far right tower to not be a winner?
When it doesn't have all the discs on it.
Okay, and how do I say that?
If the tower's count is 3.
Okay, how could I say that 3 more generically? You're not wrong in our current case, but I'm using max towers to refer to our number of towers. I can use max discs to refer to our max discs, right? The total number of discs. All right. 1 second here. So I can say keep doing this as long as what is true. This tower's count is less than max discs. Right. So this guy is a tower. His count, oh, is it called get count? One second. Let's look at our tower. No, it's a public number. So if this tower's count is less than max discs, oh, it's because I have it set as private, don't I? I do. So if I want to, I'm going to go ahead and actually leave it as private, and then we're going to give ourselves a int get count for our tower. We'll teach towers how to give us a getter for their private member called count. I'll return this count. So now a tower knows how to give us access, read-only access to its private member called count. So this guy will be get count. So we'll look at the far right tower, we'll get his count, and as long as his count is less than the max discs, we should keep asking them for more moves. As soon as we exit out of here, we will say we have a winner. All right. Go and compile this and run it again. So we'll go ahead and start moving our Right now, it's not making sure that we're playing by the rules, but that's fine. So I'll just go from 0 to 2. Then I'll go from 0 to 1. Then I'll go from 2 to 1, 0 to 2, 1 to 0, 1 to 2, 0 to 2, and now we have a winner. We probably do want to show that final state of our game too once we have a winner, which we're not currently doing. So we'll tell our game to do a final display of itself once we have a winner. All right, make some sense? So next question then, now that we have a game where we can move stuff around, the next question is where would I actually put my logic for determining whether, for example, I compile one more time. If I say 0 to 1, and then I say 0 to 1 again, we are allowing this illegal move. I want to police against this legal move. So where do I put my logic for policing against this legal move or this illegal move? If I have a source and a destination, so if this was my current thing, and I said source is 0, destination is 1, before I pop off of 0, what could I do with tower 0 and tower 1 to make sure that I'm allowed to do the move? How do I ask the question, am I allowed to pop off here and push off here and push onto here? Got nothing? Killing me. My game, this guy, he knows about all the towers, right? How do we look at the top of a tower without removing an element from the top of a tower? This is what towers know how to do. This turns into a homework assignment over Easter unless we get some participation here.
I can participate. Because I feel like I've been participating enough. No, you get the top of the tower from this top. Or you might be able to create like a tower top, potentially.
I'm showing you what towers know how to do right here. This goes back to something from we talked about after the midterm, is if you've built abilities into your your objects, use the abilities, don't reinvent the wheel. Do we already have an ability? Do towers already have the ability to show us what's at the top of the tower without removing it? I'm not asking you to operate off of memorization. I am showing you his abilities right here. Let's see, we got some chat, it looks like. We use peek, right? All right, so we can ask the peek command. This guy works like pop, but doesn't actually remove the element. Remember, stacks, our abstract data type for stack, has 3 functions: push, pop, peek. Technically, the only 2 required are push and pop. But peek is pretty useful because we could say, let me peek at the top of the stack. So you're right. We do want to get access to this guy, but this is a private member. We don't have external access to top because we don't want to be able to change it. So the way we access top is through this function called peek. All right. And let me look here at our disk. Our disk has a function that tells us the size of the disk. So we can ask, is the peak of my destination size, is the get size of that guy greater than the get size of the peak of my source? If it is, then I'm allowed to put the smaller disk on top of the larger disk. All right, so we'll go into game. So right now we have our source and destination. We need to make sure this is a legal move. Now, we know it's a legal move if it's a legal move if the destination is empty, right? So if the towers at bucket destination dot get count is not equal to 0. So we're going to say 2 different things here. So we want to say if it's either not equal to 0 and it is not a legal move, we want to move to our next iteration of the loop and not actually do this move. So, and let me, that's how I do it. Like this. Yeah. And this, the towers at destination peak. And in order for it to be legal, the get size of that peak needs to be greater than the get size of our source. All right. But really what we're doing here is we're saying, how do I disqualify this as a legal move? So if the count is something other than 0 and the destination is smaller, the top of the destination is smaller than the source I'm trying to pop. If all that is true, then this is we have an illegal move. So if there's already something on the destination tower and that something is smaller than the thing that I want to put there, I'm not allowed to move there. So since I'm not allowed to move there, I want to just move on to the next iteration of this while loop. And I want to skip all this stuff down here. And I do that with continue. Continue says, remember, break says get out of this loop entirely. continue says skip to the next iteration of this loop. So we will move past this stuff. So I kind of look at this like it is a like a little minefield. Okay, so I have a little checkpoint here that says, look, if there's something in the destination and that something prevents me from making this move legally, which means the size of it is actually smaller than the size I'm trying to put on top, because I'm not allowed to put a larger disc on top of a smaller disc. If that's the case, I'm just going to ask them for a new move. In fact, we can even give them a little see out illegal move. And we'll even give them 2 little indels so we have the spacing similar to what we had before. So if it's an illegal move, skip this stuff and move on to the next iteration, asking them for a new source and a new destination. If we get past this little minefield, that means it was a legal move, right? Now, this guy, what if, so we haven't actually quite gotten legal move yet. So we get past this guy. This whole thing is true if the destination has something in it and it's legal, or this. Let me think about this. So if get count is not equal, so if get count is equal to 0, this whole thing will be false. So we'll go past it. So we're okay. So this covers our butt for the, if there's nothing in the destination, we don't need to check to see if it's legal. So we'll just pass through this because an and will be false. Because if this guy is equal to 0, 0 equals 0. So this will be a false statement. 0 is not equal to 0 is a false statement. Therefore, it doesn't matter what the second part of this is, and will be false. So this will be false, which means we won't do this and we'll actually make the move. All right. So this should now allow us to make only legal moves. If it's illegal, scream at them, ask them to do it again. Otherwise, we get past this if statement by not going into the body of it, and we actually make the move. All right, so let's try to give ourselves an illegal move here. So we'll start with bucket 0 and we'll go to bucket 1. That was legal. Now we'll go from bucket 0 to bucket 1, which should be illegal. And it was not illegal. We have our thing upside down. The destination has a count that's not equal to 0, which is true in this case. And the destination's peak get size is less than the source's peak get size. So it looked like this. So the destination's peak get size is 2. Is that less than this guy's peak get size, which is 4? Well, actually, this guy's get size is actually 1. This guy's get size is actually 2. So is 1 less than 2? It is, which means that that will be a true statement. The destination has something in it, and the destination size, which was a 1, is less than the source's size. If that's the case, we should say illegal move. So this get size is either not working or we're not setting up our disk correctly in the constructor. So let's look at our disk here. Get size should be pretty straightforward. It just returns the size. So we actually setting size correctly. Size of the disk is equal to size. Well, let's go ahead and print that out inside of here. We'll do a cout, the get size of the destination. And we'll do a cout, the get size of the source. So it's destination first. Well, here we'll actually. Make sure these guys are reporting their correct size. So we'll go 0 to 1. All right, so destination was 0. Source was some ridiculous number because the second guy didn't have a, oh, wait a minute. Oh yeah, destination tower. Wait, no. Destination was 0. Source was, my source should have been a 0. The peak of source was the top of this guy. Why is it giving me this gigantic value? So that means our tower is working incorrectly. Because now if I go from 0 to 1, those are not the correct sizes of the top of our towers. So our peak and pop are not working the way they should be working. Well, actually, let's look at push to make sure. Oh, because we didn't write peak. That would make a lot of sense here. So I'm actually going to write peak in terms of pop. This will be nice and easy. So we'll do disk temp is going to be this pop. And then we'll say this push temp. So this will give me, I'm going to go ahead and pop it off the tower, give myself a pointer to it. Then I'll go ahead and push it back on, but I still have that pointer. So now I can go ahead and just return temp. So that's effectively peak. Similarly, I could have just said, because I'm inside of tower, and tower has top as a private variable. So I could have also done return this top. These two guys will do the same thing. This is probably the better way of doing it, but technically I could pop it, then to give myself a pointer and then push it. But the reason this wasn't working is because I did not write peak. We planned on writing it, but didn't actually write it. So we'll go 0, 1. All right, so we're getting the segmentation thing right now because this guy didn't have a peak. So that's fine. Now we're back to where we should be. We're getting that because we are trying to print those guys out without checking. This guy. So we'll take those out. And now we'll only check the destination if it had a count that wasn't equal to 0. Go 0 to 1. All right, now we'll go 0 to 1 again, and this should be an illegal move. There's our illegal move, didn't let us let us do that. So we'll go 0 to 2. Then we'll go 1 to 2. We'll go 0, we'll try to go to 2. That's not going to be allowed. Illegal move. 0 to 1. Then 2 to 1. We're not going about this very efficiently. 2 to 0. 1 to 0. 1 to 2. 0 to 1. 0 to 2. 1 to 2. And there's our winner. All right. Then the last thing that we probably want to do to kind of keep up with kind of what we looked at as that online thing is we want to count the number of moves it took. And we can do that inside of our play. So we'll say int num moves. We'll start off at 0. Only when we actually make a move do we want to say num moves plus plus. If we are inside here and it was an illegal attempt, we're not going to increment num moves. So now we can say we have a winner in num moves I'll just say in num moves. So we'll output the actual number of moves that it took. All right, so we'll go 0 to 2, 0 to 1, 2 to 1, 0 to 2, 1 to 0, 1 to 2, 0 to 2. So there's our 7 moves to do our 3 discs. All right, so we can probably say that's a functional Towers of Hanoi game. So I've pushed that up to GitHub. Are there any questions about any of that? We built our stack data structure, hid it inside of a tower. We applied some extra rules to it other than normal stacks, where we said we're not allowed to push a value that has a size larger than the value that's currently at the top of that stack. And then we gave ourselves a little user interface that kept asking us what our source and our destination tower was, allowing us to move disks around. So questions about any of that stuff? Okay, so then what we're gonna do is I won't give you homework over break. The next time we will meet is next Tuesday, which actually, so we don't even miss a class, right? Today's Thursday. You have break tomorrow through Monday. I'm pretty sure classes that start after 4 p.m. today are not on, and classes that start after 4 p.m. on Monday, I think, do meet. I'm not positive on that one though, so you might want to double check that. But the next time I'll see you is on Tuesday. And what we're going to start looking at is nonlinear linked data structures. So we're going to look at binary trees on starting on Tuesday. So I'll go ahead and actually add that to our, because a queue is a lot like a stack, except we add stuff to the end, we remove from the front. We've already written that with linked lists, so I don't think we need to beat a dead horse there. So we'll go ahead and add a slide. Binary trees. Start here on Tuesday. All right, questions, comments, concerns, bribes. All right, everybody have a good weekend. Travel safe if you're going somewhere. Yada, yada, yada. Oh, and an update, I guess we're meeting at Highland House today at 1 instead of Crave at 3. So if you are interested in coming and hanging out, watching the Brewers game or something like that, we're meeting near campus at 1 o'clock. So feel free to come and bring your friends or whatever. All right, I will see everybody later.